Another thing that University of Waikato people did, this is one of the students, they took these piston cores to have a look to see if they could find that Rotomahana mud on the lake floor and other things if they were incorporated within that mud. So they could, this is about 2/3 of a metre, I believe, and they describe it and see what's components and so on. And quite interesting is this material up the top. This is a flocculant, which a lot of it is organic material falling down through the lake and accumulating on the lake floor. And there are these worms. I'm not sure if these are the worms, but there's these worms in there. And this has great relevance later on because it's very, very soft material. So when those AUVs were going along through the lake, they're mapping the lake floor. When the lake floor is very sloppy like this, it's very difficult for them to get returns from the signal, which I'll talk about in a moment. So remember this photograph, because this was a bit of a problem for us when trying to map the lake. Some of the other equipment we used, and we haven't got to the AUVs yet. Over here is a camera system from Woods Hole that we put down to try and see if we could ground truth some of these other things we're seeing or actually get images from the lake floor. And this is a very special instrument called a CTD. So it measures the physical properties through the water, the temperature, the conductivity, depth, all sorts of things that we have here are hanging off it. And then what we'd put, these are bottles called Niskin bottles, we put them on the wire so as it goes down through the lake and it's measuring all these different parameters as it goes, we can collect water samples all through the lake. So this is where we did this. Cameras, stations are all in red, and these water sampling stations are all in black. So mostly we concentrated by where we saw activity going on, a little bit down here, mostly up in the area of the old pinks and some of these smaller places that I showed you previously. So it doesn't matter about the details here, but it's just to show you some of the things that we do. For example, the typical lake profile for temperature is this white line, which is probably a bit tough to see at the back, but anyway, the blue line, which was one of the stations, has these real spikes in it. And whilst that might not seem much to you in terms of a temperature, that's quite significant in terms of what we do, because it's a bit like if you're in a bath and the bath is quite cold, or you can have a warm bath if you want, and somebody gets a syringe and they inject warm water into your cold bath or hot water into your, or the other way around, cold water into your warm bath, whether you would actually notice a difference. And almost certainly you wouldn't notice a difference at all. So when you can measure anomalies like this in a big body of water, it means that it's quite significant. There's a lot of hot water coming out. So some of these profiles showing that it's getting, there's some definitely hot water being discharged. This is a measure of the turbidity, or how much stuff is in the water column. And you can see a typical clean profiles down here, and some of these stations says there's a lot of stuff moving around over these hydrothermal vents. And this one, which is probably the most technical, it's just telling you how fresh is that hot water coming out of the vents. And because it's quite a bit shifted, I can tell you that it's pouring out as we were doing the surveys. Another thing that we could do, this is actually just time. So time that we have the instrument dangling down on the bottom of the lake floor. And this is the topography at the lake floor, and these are the temperature anomalies. And that's very significant. So there's no doubt that there's quite a lot of hot water in some places, also represented by this in some places of the lake. So we're building up to the best stuff, all right? This is just a teaser. So the photographs. And I'll show you the photographs in a couple of places because I think it's more pertinent to distribute them through the talk. So here the University of Waikato boat that we use, which we were very grateful for. This is just a makeshift camera. We have to have lights, obviously. It's pitch black down there. These are very high resolution digital cameras. And some of the things that we saw, some of these sort of caps of material down there, this is all siliceous material. Things like this, hard for you to tell, but you have to believe me that these are sponges. So here, that's an interesting thing for biologists. So in 1886, this entire lake got excavated, I mean completely excavated, so there's not a drop of water left in the lake. And 125 years later, this lake, at the bottom of the lake, at 125 or thereabouts, 120 metres depth, is colonised by sponges. So I'll just leave that for you to ponder. But I mean, that is an incredible sort of evolutionary thing that these guys can go back into there and colonise the bottom of the lake in 125 years. other things. This is remarkable. Does anybody know what that is? It's ripples, right? You see them on the beach all the time. But here you've got in the bottom of the lake, so we're seeing these ripples, and that's quite remarkable too. And I think, remember this photograph as well, because when I show you what I believe to be the terraces, I think part of the reason why we're seeing the terraces is because there are these currents that are winnowing things along the lake floor, and I think that's helped us reveal the bottom couple of terraces. And then there's all this material. It's sort of strange material. Some of it's a bit hard, and the white stuff is all that what we saw in that core. Remember that very sloppy stuff. So just some images of the bottom of the lake. And there are some lavas. And we know when we hit this lava because the vehicle drove straight into it. So it wasn't very popular at the time because they're, I won't tell you how expensive they are, but anyway, so there are plugs of lava down there, which we found the hard way, but are not on the maps, by the way. So here's one of these AUVs, autonomous underwater vehicles. These are small ones. There's some bigger ones. We just had a cruise offshore New Zealand with a very big one called Sentry, which is worth about $8 million. This one is quite a bit cheaper, but nevertheless, packed in here is an incredible array of sensors and so on. And these vehicles are monitored on shore. There's a system that we can use with beacons, and we have transponders under the water. So they talk to each other, and they talk to the vehicle, and the vehicle talks to the beacon, and the beacon talks to the satellite, and it comes back to us. So we know where this vehicle is within a couple of meters on the lake floor at any time. And it's all ultimately translated back to satellites and so on. So it's a very, very high precision way of mapping the lake floor, and it's definitely state of the art. So as I say, here's one of them. These ones can be carried by a couple of people. And Andrew spoke of this. This was the first day. It was absolutely abysmal. The weather was unbelievable, but it actually was pretty good most of the time. We were lucky. So we managed to do the job.
One of these was used on Lake Rotomahana to locate the young boy that drowned there.
Yeah, that's right. So the Navy has these, and they use them for different purposes. But the beauty about these particular ones that we have, they have infinitely more sensors on them than they typically use. So we had probably, arguably, the best equipment in the world here for the 2 weeks. So this is another way that we transported them, a far easier way, that Brad here would go and pick them up when they're in trouble or they need to be deployed or whatever. And you simply just take them off, and this is Amy, and she'll just let them go, and off it goes. And I thought it was quite a poignant picture. Here's the steaming cliffs in the background, some of those geothermal features I showed previously back there, and off it go. And at some point it submerged and go and do its business. So very amazing pieces of equipment. So this will be difficult for you at the back, but it doesn't matter. You'll just have to believe me. This is Hochstedter's map, which is before 1886, that's for sure. So prior to the eruption. And this is when the German geologist came out here, and he was really taken, like so many people, by these terraces. And these are his rendition of the lake and the location of different features. And here's the Pink Terraces by he, and here's the white terraces, and then there's another number of other features along, at that time, the existing lake. This is the island today. This would have been a prominent part, a hill in the past. So this is where he saw the pinks were, and you guys can't see, but up the front you can see, and you can tell. Here's a little wee hook of land, just there. Comes down, and there's a little wee hook, so you guys can just all nod, and everyone will agree. Now this is a great friend of mine, Ron Keane. He's a professor up at Auckland University. He taught me geophysics way back, and he's been working, as many of you might know, he wrote the book about Tarawera. He's a very interesting man. And what he did here, we just put this on a computer for him, but he made this map from photographs. He did it in 1959, but from all the photographs of pre-1886. And what you can do with these photographs, you can get the angles correct, but you can't necessarily get the distances correct, but the angles. So everything with respect to each other is correct. So I just want to point out, this is that original Rotomahana lake. Here's the white terraces he had, and here's the pink terraces. And here's this hook that Hochstetter had in there, okay? Same promontory sticking out into the lake, that Hochstetter had. So this is a really important thing. So you've got to remember this, because if you look around the lake, there are very few places that are particularly obvious, but that's one. So this is what the vehicles did. Different vehicles, different days, different times, and they would invariably map in a grid pattern. It's much easier for them to go up and down, like mowing the grass, really. And yes, there are some places that are not covered, but those of you who know the lake know that this is incredibly shallow in here. It's very shallow all the way through there, and there's no way they're going to stick the vehicles in there. And there's also a lot of weeds and stuff down here, so they would just get bogged down, and it's a waste of time. So this is essentially about 85% of the lake. That's important. Now, one of the instruments does what's called side scan sonar. So it has a sensor on it that sends out a sound or an acoustic wave, and it pings it down onto the sea floor, and it hits the sea floor or whatever's on the sea floor, and it comes back. Now, if what's on the sea floor is hard, that return, it's like your echo sounder on your fish finder, comes back quite quickly. And if whatever on the sea floor is quite soft, it doesn't come back very quickly at all. So then the instrument is very fancy, and it can determine how hard what things are down there just by these signals coming back, the speed at which they come back and how long it takes. So this is the track of one of the vehicles. And also what happens is that if there's something in the water column that interferes with the signal, it will tell it. And what this is, these are all huge bubble plumes. So remember we saw those jets coming out from on the fish finder? Well, there are hundreds of pits all over. And this is just one swath by one vehicle and one little part of the lake. So this is down in the south where I said there was a lot of new geothermal activity. So all of this is representing, you can see it, the bubbles coming up, and they're coming out of these craters. And going back to the photos, we'd put the camera down and we see all these bubbles, and we know from our work from our other colleagues that most of these bubbles are CO2 or carbon dioxide. And then here's one of these craters. You can see it. It's probably about a metre or a bit more than a metre in diameter, and you can't tell, but coming out of the centre of this thing are all these bubbles. You can see them going up. So it's like pockmarks on the moon, except a much, much smaller scale. But each one of these is the centre of an outpouring of a lot of gas. A lot of gas. Now, something else, one of the other vehicles, what it did, it measured the bathymetry. And the bathymetry is the marine equivalent of topography. So it's measuring actually what is on the lake floor, what is the surface of the lake floor. Now this is the old data that was done in the mid-70s. And when they did this, they did a spacing of 200 metres. So they can't really see things much smaller than 200 metres. So I want to draw, there's lots of things to say, but I just want to draw your attention to here. You look at this one, and this is the new data. There's something very different happens here. All right? This looks familiar. That looks very familiar to me from Ron Keem's work, and also from Hochstetter's map prior to 1886. And one of the reasons I believe that people have always thought in modern times why we couldn't possibly have found these things is because the information says it's not there. But this is a very crude, compared to what we did, this is a very crude map. It's like if you need your glasses to read your books, this is like with your glasses off, and this is like with your glasses on. And you can see there's a very big difference. There's a hole here in the map because there's a big, huge pillar standing up, which the vehicle drove straight into. And we know what that is. That, oops, I've missed it out. I'll show you later on. This is what they call the pinnacles. So anyway, this part here, very important to remember that. All the rest around here is just very shallow, so it doesn't matter. You can also see here, the purples are deep, the browns and that are very shallow. That there's a couple of things. It's quite deep through the middle, not surprising. We've got this promontory up here. I can tell you this big pillar of rock sticking up there. And we've got these two. This deep part is going off through here, and we've got another less deep part going off towards Mount Tarawera.